Lesson 5.1 is polynomials. You guys have seen polynomials before, okay? This is not brand new, especially what we're doing here at the top. This is not new, okay? Definition here, a polynomial is the addition and subtraction of x values with real number coefficients and whole number powers. Okay, guys, think about the equations we worked with last chapter. You could have seen a problem on your test yesterday of y equals x squared plus 7x plus 10, yes? Or x squared plus 7x plus 10, you could have been told to factor. Right there, that is a polynomial because it is x squared plus 7x plus 10. It is addition and subtraction of x values. There's real number coefficients, whole number powers. Now, we're going to do several things with this. One thing is we're going to put these in standard form. You had standard form yesterday, yes? What was standard form of a quadratic? Yeah. Ax squared plus bx plus c. And think about your powers. What do you notice your powers there? You start with x squared, and then it's x to the first, and then no x. So x to the 0. So that's the idea of standard form. Standard form of a polynomial is when the polynomial is written in decreasing degree. So you're going from biggest power to smallest power. Okay, so that's standard form. That's one thing we're going to be doing. Another thing we're going to be doing is naming the polynomials. The first side, the left side of this chart over here, we're going to be naming polynomials based on their degrees. And when we find degrees, we are looking at their highest exponent. For instance, you know that whole x squared plus 7x plus 10 thing? The highest power is a 2, and so guess what that's called? It's a quadratic, which is what our whole last chapter was about, was quadratics. So if the highest power is 2, it's quadratic. If the highest power is 1, it's linear. If there's no power, for instance, just the number 5, that's a constant, and that's a degree 0. If the highest degree is 3, like this one, 4x cubed, that means it's a cubic. If the highest degree is 4, it's a quartic. Highest degree of 5, it's a quintic. So when you're asked to name it based on degrees, you're looking at the highest power and using those names. And then the other half of this chart is naming based on how many terms there are. So, for instance, this example right here, 5, that is just one term, yes? If there is one term, then we're going to call it a monomial. So mono standing for one there, one term. If there are two terms, such as x plus 4, that's two terms, we're going to call it a binomial. Kind of like a bicycle, binomial. And then, think about the example I gave earlier. X squared plus 7x plus 10, that is 3 terms. So if there's 3 terms like this one, it's going to be called a trinomial. So monomial is one term. Trinomial is 2 terms added or subtracted together. Trinomial is 3 terms added or subtracted together. That's the highest names we have. So if you run into a situation like this bottom one where there's more than 3 terms, so in this case there's 4 terms, it gets a generic name of polynomial with 4 terms.
Does that continue however?
Yes. So it could be polynomial with 5 terms, polynomial with 6 terms, whatever you need to say there.
Are we going to be naming them using like both of them? So
Yep.
a linear binomial equation?
Yep, we're going to name them together. And so between those two names and standard form, that's what we're practicing in this first section here. So, directions say, write each polynomial in standard form. And then what is the classification of each polynomial by degree and by number of terms. So we got 3 things to do. But it's an easy 3 things. So thoughts on standard form on part A.
Do we just like reorganize it so it's 9x plus 3x plus 5?
Throw the squared in there and you got it.
Oh yeah.
So reorganizing it, write it in order from highest power to lowest power. This one is 9x squared plus 3x plus 5. Notice I didn't order the 9, 3, 5. They're just along for the ride. They go along with the terms. Are we okay with standard form there? Highest power to lowest power. X squared, x to the first, and no x. Now we have to name it. So first of all, let's name it based on the degree. What are we going to name it based on the degree? Quadratic, because the highest power is x to the second. So I'm just going to write x to the second here as a hint. And that is quadratic. Oops. What about terms? How many terms are there? 3. So if there's 3 terms, we're going to call it a trinomial. So put it all together, and it is a quadratic trinomial. That wasn't too bad, was it? Well, I told a class earlier today, we've done a lot harder than this. So.
Could you flip-flop the names? Like, could you say quadratic trinomial or trinomial quadratic?
Yeah. And I'm just more making sure we're all understanding, trying to, okay, what's it based on degrees? Then what's it based on terms? Just make sure we get all the pieces here. Okay, B. What are your thoughts on standard form here? I think if you said the right, yes, we need to combine something. Did you say the right numbers? Okay, yes.
You said -2 and then.
Okay, I'm not imagining. Okay. Okay, so the key is here. Okay, obviously the first term is x to the 4th, yes? What comes after x to the 4th? Well, it's not a question of does negative 6x squared come next or does 10x squared come next? Those are like terms. So you need to combine like terms. So negative 6x squared plus 10x squared is 4x squared. So x to the 4th plus 4x squared, and then what? Plus 4x minus 12. So yes, please, anytime you have like terms that can be combined, combine them. And always make sure to combine like terms before you name it, because that can affect your name. Okay, how do you want to name this based on degrees? Okay, highest power is x to the 4th, and that makes it a quartic. Okay, and then we reduced it to 4 terms, but that's as far as we can go. So since there are 4 terms, polynomial with 4 terms. Okay, what do you guys got on C? Okay, 5x to the 4th plus 3x to the 3rd minus x is my standard form. Highest power is x to the 4th, which makes it quartic. And then I have 3 terms being added and subtracted, and that makes it a trinomial. So when I say it, I would say quartic trinomial. But I'm more about, do you have the 2 names you need? Okay, part D. Standard form.
Negative 4x to the fifth.
Okay. So notice she took the negative with it, negative 4x to the fifth.
Plus 2x squared.
Plus 2x squared
Plus 13.
plus 13 because 3 and 10 are like terms. And
It is, let's say, quintic trinomial.
okay, highest power is x to the fifth. Definitely makes it quintic. There are 3 terms, which makes it a trinomial. Yes.
Are there names for degrees hierarchified? Yeah, polynomial with 5 terms.
Maybe
Degrees hierarchified.
degrees. Well, because there are abbreviations, like 8 is octo, those kind of things. I don't know.
On my study island,
I don't know if we name them using degrees. So,
Okay. It was like.
but I mean, this is the highest you'll need,
Nice.
at least as far as my knowledge. Now, with the homework, I will give you guys a heads up. Homework. Obviously, this part will be pretty easy. The bottom part, I think, will be pretty easy in homework too. It may take me a few to get it explained to you, but give me a chance, okay? But homework is only 11 questions, if I recall. And a lot of it is like drop-down boxes. Because if you're doing the type of ones we just did, they're going to give you a drop-down box. And you have to do those. So I think the homework, I really think the homework should go pretty quickly. I think it'll be one of those like 10-minute type homeworks that you'll enjoy. Well, enjoy in the sense that,
It's fantastic.
yeah. Okay, so you guys ready to talk about the bottom part? Okay, the bottom part, you'll notice it says graphing cubic functions. You'll notice they are all cubic functions we are graphing. LOL. We're going to graph 2 of them together to look at them. We're not going to graph all of them, but it's asking what is the graph of each cubic function to describe the graph. First of all, in homework, I don't think you have to graph any. It's more about the descriptions here. And when we describe these, we're going to do 2 things. We're going to talk about end behavior and turning points. Okay? And end behavior kind of leads us into pre-calc. So we talk about end behavior and pre-calc. But, so I'm going to write that right here. Determine end behavior and turning points.
Pardon the interruption. Maggie Dolworth, I need you to report to the middle school office, please.
So that's what we're going to be doing here. Again, give me a chance. I'm going to make it make sense. At least I think I am. You'll tell me at the end if I failed. So as we look at example A, y equals 1/2 x cubed. Think about y equals x cubed. I feel like we've talked about it at points. Can you guys visualize a graph for y equals x cubed? What are you thinking?
Thinking up and down. So if it's y equals it.
Y equals x cubed. Do you remember what that graph looks like?
Well, x squared is a parabola. X is a line. Is it just is it like a parabola with the normal ones, like the 0, 0, 1, 1, 2, 4? It goes up. X cubed? I thought you said squared. Okay.
No,
cubed is
x cubed.
I thought you said x squared. I don't know what x cubed is.
No?
I don't know what x squared was.
Maybe is it sideways? A sideways parabola?
No.
Well, I tried. Is it like not a parabola? I knew it. It's a squiggly line. Okay. No, you said parabola. No, I said x.
Y equals x cubed. Okay. And I've had a few people today kind of remember it, like we've talked about it previously, but not a whole lot of people have. So y equals x cubed is just a curve, a squiggle. Okay. Now there are other variations of what y equals x cubed can look like, but if it's just a basic y equals x cubed, that's the gist of it. Now the particular example that we're working with is 1/2 times x cubed. What's multiplying by 1/2 do to the graph? Think about what we've done several chapters in Algebra 2 this year.
It's going to either stretch or compression. Yeah. If it's less.
It's a vertical stretch or shrink or stretch or compression. Yeah. Since this number is since 1/2 is a number between 0 and 1, it's going to compress it. Okay. And so my point is that y equals 1/2 x cubed. We're going to graph it here at the end, but it's basically going to look like this graph I just put on the board. Okay. Now, I want to talk about end behavior with that. End behavior is what it is doing at the ends. At the ends, meaning what is the graph doing at the left end and what is the graph doing at the right end. So where is the graph going? So as I look at this, where does my graph go on the left end? Or in other words, where does it start? It's starting from negative, or it's starting from the bottom, right? Okay, so it's starting from down at the bottom. This end, so it's starting down. That's what I'm trying to get to say. This is starting down. We draw. Where does it end on the right? Up. It's going up, yes? So this graph has end behavior that is down and up. Meaning on the left end, as I go the farther left I go, where's my graph going? It's going down. The farther right I go, where's my graph going? Up. So this end behavior we call just that, down and up. Okay. Your choices on end behavior today will be down and up and up, or down and down. So basically any of combos of the 4 words. And I'm going to show you, I'm going to talk about them, okay? But I'm just, that's when you're asked for end behavior, we're using those words. Now,
as you're stretching the press, does the line get more squiggly and tighter, or no? So
it just, compression means it would, so a stretch is going to kind of, I don't know if that's stretch name, but a compression, it kind of squishes down more there. I don't know if that makes sense or not, but
it's kind of
like stretch is going to kind of
straighten it out a little bit more.
Makes it skinnier in a way, straighter, whereas this one, I don't know. I'm trying here. Yeah. Okay. Okay. Now, the other thing besides end behavior we have to talk about is turning points. This graph that I drew, it curves here, but did it ever turn and go a different direction? If I start down here in the bottom, I was always continuing and going up, yes? So this is an example of a graph that has no turning points. And what I can tell you at your stage is you guys would know this has no turning points because the only term here was an x cubed term. There would be turning points if there were other x terms, like if there's an x squared term in there maybe, or an x term, those would cause turning points. Because it's just an x cubed, that's the only x there, there are no turning points. So I'm going to write that down because turning points is something you're asked about in homework, I believe. How I want you guys to know that there's no turning points. There were no other x terms.
Can we say that there's only an x cubed? Like saying that
As you want to say that's the only x term. Because if we had x cubed and then a constant added or subtracted, it would still be the same graph, just moved up or down. Okay? Now, I want to talk about this graph. To set this up, we're going to do a quick XY chart. Good values to use in my XY chart. negative 2, negative 1, 0, 1, and 2. And what is the equation I'm plugging into? 1/2 x cubed. So put in negative 2. Negative 2 raised to the third. Negative 2 times negative 2 times negative 2. Negative 8. Half of negative 8. Negative 4. Okay, put in negative 1. Negative 1 times negative 1 times negative 1. Negative 1. Half of negative 1. Negative 1/2. 0 times 0 times 0. Half of 0. 0. 1. 1 times 1 times 1. Half of 1. A half. 2. 2 times 2 times 2. Half of 8. 4. Okay, let's sketch a graph of this. Obviously, you need to be able to graph left and right 2, up and down 4. So negative 2, negative 4, left 2, down 4, left 1, down a half, 0, 0, right 1, up a half, 2, 4. Does that graph agree with the answers we gave? Does it have down and up in behavior? In other words, we start down and we're ending up. Or as we go left, my graph will extend down. As I go right, my graph will extend up. Turning points? No, my graph never turned and went a different direction.
Like a U-turn?
Yeah. Like it's going up and then it turns and goes down. That's a turning point. Yep. And again, I'm going to tie this all together by the time we're done, okay? So you're going to see turning points. Okay. You ready to talk about B? So, it's 3x minus x cubed. What is the important term to look at? We need to look at the x cubed term, right? That's the important one to look at because you have to look at the highest power to determine end behavior. Okay, we have to look at the highest power. Now, as we look at this x cubed, notice it is negative x cubed. How does that affect my graph?
Flip-flop the ups and the downs?
Yep.
Oh.
Just like, okay, here's my connection. What's a negative in front of a parabola do? It was up and then it goes down, right? So a negative x cubed, and again, we'll get a picture here in a moment, does that. Okay? So, end behavior. What would you call end behavior if it's a negative in front of x cubed? Up and down. Because as you're going to the left, my graph is going up. As we're going to the right, my graph is going down. So my end behavior is up and down. Based on what I have said so far today, what would you guess about turning points on this problem? Is there another x term besides x cubed?
Yes.
Yes. So you will expect most likely to see turning points. Now, here's what I will tell you. So when you have something like this, the power is x to the third. At most, there can be one less than that power number of turning points. So 1 less than 3 is 2. So at most, there can be 2 turning points. The other thing I have to tell you is turning points always have to occur in pairs. Because if you were going up, you turn and go down, then you still have to turn and go back up. And so turning points occur in pairs. So in a cubic, your options are either no turning points or 2 turning points. Those are your only options. Okay? So in this case, we're going to expect to see 2 turning points.
Can I write that down?
Yep. I'm writing it down right now. And how did you guys know that there were going to be turning points? Yeah, there were other x terms, right? Other x terms existed. I mean, there's other ways to know it, but at your level, at this point in your lives, that's what I'm trying to get you to identify, okay? First introduction. I'm going with the basics as much as I can. I want to graph this one. It's the last one we're going to graph, but I want you to see the example of up and down behavior and 2 turning points. So XY chart again. Same X values. -2, -1, 0, 1, 2. This time I'm plugging into the equation 3x minus x cubed. So 3 times the number minus the number cubed. Okay, first number to plug in, -2. 3 times -2, -6. -2 to the third, -8. -6 minus -8.
-6 minus -8.
-6 minus -8. So it really becomes -6 plus 8, which is +2. Okay? Change it up. This time I'm plugging in -1. 3 times -1? -3. -1 to the third. -1. -3 minus -1. -3 plus 1, which is -2. 0 ends up being 0 minus 0, which is 0. Plug in 1. 3 times 1? 3. 1 to the third. 1. 3 minus 1? 2. And plug in 2. 3 times 2? 6. 2 to the third. 8. 6 minus 8? -2. So we're going to go left 2 up 2. Left 1 down 2. 0, 0. Right 1 up 2. Right 2 down 2. I'll give you a hint, it's not an X.
How do I connect it to the
X. It's backwards. It's backwards.
That's like a little squiggly.
Okay. Here's the deal. You connect your dots basically in the order we put them in, because you're connecting your dots as you move left to right, as your X values go from left to right. So I'm actually going to start up here, and then we had this one down here, up through 0, 0, up top, and down.
Yeah, mine definitely doesn't look like
They're technically curves. They're not, I mean, it curves. Okay. Now, does my graph make sense with the answers we gave earlier? Do I have up and down behavior?
Yes.
It starts up here. It ends down here. Did I end up with 2 turning points?
Yes.
Yes. Okay? Now, because I want to make sure I don't run out of time for the chart, we're going to do the chart, and then we might go back and talk about, I'd like to talk about C and D as well, but I'm afraid I don't want to run out of time. Make sense? To me, the chart is important. We're not doing any more graphs, so the bottom half over here, I'm going to make a chart. The top half, I can fill in answers if we have time. I am making a chart for A, X to the N. My chart is going to have 2 more columns after that, one of which is what happens when N is even, another of which is what happens when N is odd. And then I'm going to add 2 rows down here. The first of which is what happens if A is positive. And then the other one is what happens if A is negative. So I'll give you a moment to get your chart set up so then we can talk about it. Because this chart is what I'm going to suggest you have beside you when you're doing homework. Because keep in mind, all we've talked about are cubics today, right? And we talked about our quadratics a little bit. But these rules apply to any powers. And we'll talk about it after the announcement.
Board of Interruptions, have your attention for a few end of the day announcements. We need to do the following students in the high school office. Augie Mueller, Aaron Hoback, Colin Earl, and Abby Hoback. Please come to the high school office. Cheerbach, it's not too late to buy your shirts and tickets. If you have money, you can come down to the office right now. Congratulations once again to the prize winners. Middle school, we have Katie Graves and Autumn Hurt. In the high school, we have Maggie Lewis and Hope Williams. Congratulations. The rescheduled date for the ASVAB is December 13th. That's next Friday from 8 to 11 in the high school gym. You are to have no cell phones. You report directly to the gym. And you see this is for none if you are not sure if you're taking this. This is a juniors and seniors test. FCA shirt and sweatshirt orders are due today, and if you're going to Open Arms on Monday, please let Mr. Garner know before you leave school today. Take an administrator to the wall on the 18th. Starting next Monday to the 17th, you can bring your loose change in and vote for administrator to be taped to the wall. $1 for 3 foot of tape. Toys for Todd. Please don't forget to bring new or slightly used toys. And for Toys for Tots, there's a box located in front of the auditorium. The Sweet Shop is now taking orders. Please make sure and get your orders in. There are order forms in the bookstore, the office, the library, or the classroom. The last order date is December 17th. And wear your Christmas sweater Friday the 13th and enter the Student Council Ugly Sweater Contest for $1. One winner will be chosen from each lunch. There are prizes for this. In athletics this weekend, tonight we have the boys basketball at home against Talon at 6. Tomorrow, girls basketball will be at Faith Christian at 11. Wrestling will be at McConaughey for the invite at 8:30. And high school boys basketball will be at Frontier at 6 o'clock. So best of luck to all the teams. Thank you. Have a great weekend.
Okay, so our focus today. N was odd on the ones we focused on, yes? Because we did x to the third. So n refers to the power. When n was odd, so is x to the third. Keep in mind, this applies for not just x to the third, odd numbers, x to the third, x to the fifth, x to the seventh, x to the ninth, any odd power. What was true of our n behavior when a was positive? What was my n behavior? It was down and up. So anytime you have an odd exponent and it was positive out front, you're going to have down and up in behavior. What if it was x to the third, x to the fifth, x to the seventh, but a is negative? It switches, it's up and down. Now, we didn't really focus this on today, but what if n is even? Our even example you guys know is x squared. What's in behavior on x squared when it's just y equals x squared? Up and up. So whether it's x squared, x to the 4th, x to the 6th, x to the 8th, if a is positive, in behavior is up and up. What if there's a negative out front? Down and down. Okay? Use that chart to help you out. I think it will, I think you'll be able to do okay. If not, we'll talk Monday. Okay? About the best timing I could get. Without the announcements, we would have been just fine.